Hello. So, good morning all. In these sessions, we'll discuss IoT ecosystem and its connectivity. So basically, if we look at the architecture of IoT system, so what we have device connectivity, then we have data processing analytics, and lastly presentation. So these IP capable devices are used to collect the data. Like suppose say we have IoT client, existing IoT system is connected to that IoT client. We have low power devices. Now these systems are connected. IoT system is connected to cloud with the help of some gateway. Okay. We can track the data, look at the data flow. An optional solutions is given for the component. Now either you can connect this IoT system directly to cloud system, or you can use some kind of gateway to collect the information from IoT devices, and then it will get sent to cloud system, and then the data will get processed at cloud, and finally it will get sent to that user or operator, we can say. Then look at the Azure, Microsoft Azure IoT system. So how that data will get collected and how it will get stored, how it will get analyzed, and how it will get presented. So this is the example. So basically look at the data. So from producer or from various, we can say operating devices, we can collect the data. Now to transport the data, we have some service hubs, or we have some client, heterogeneous client agents are there, or external data sources available. With the help of this, the collected data will get stored. Again, for storage, we can use SQL database system, or we can use some table or blob storage, or we can use document DB, or we can use some data source to store the data. Then we have to analyze that data. To analyze that data, we have machine learning algorithms, or we have some SD Insight Storm. We have Steam Analytics, we have cloud services. Based on this facility, we can analyze that data, and lastly, we can present that data required format. Like suppose for Azure website, we can collect the data, store, analyze, and present that data. Like for mobile services, for notification apps, for Power BI, for external services. So these are the some kind of presentation forms of that required data. Okay. Then next, how we can use some predictive maintenance. What is the pattern? What is devices and cloud pattern of that system that is given? So we have discussed the part of devices which are connected to system. So either we have Windows, Android, or iOS that are connected to cloud system with the help of some gateways. Okay. So this will come under the device connectivity and management. Okay. Then next we have analytics and operations. So previously we have seen that part. Either you can use some data analytics system, you have some machine learning, you have some documents DB, or some stream analysis is there. Okay. So again, it is based on business logic. For path analysis, we can select that particular uh, parameter or types of analysis. And then finally it will get present. So presentations related to app based or website based or for service based or some business kind of business plan, and from some business plan, that data will get presented. Okay. So this is the overall pattern for predictive maintenance, and look at the data traction. For each and every route, that data will get tracked and it will get presented to customer, or we can say particular uh, operator. Okay. So these are the example of architecture. So look at the information. Real-time data will get collected. So basically, these are the external source of data storage. Like we have SQL server. Okay, we have real-time temporary data arrangement. Then that data, suppose say if you are measuring some data at that particular system, we can store the data at Azure Data Factory. Okay, and for analysis purpose, we can use some stream analysis, and finally we can use Power BI for some stream analysis. The batch updations or predictions, the same store data will get transferred to Azure Data Factory. Okay, and the this is the overall process how that system can work on a single batch. Like AML model is there, machine learning model is there for web service or BSA endpoint. So based on this information, either we can store the data at external devices, we can process that data with the help of SQL or BML, or we can say AML model. And with the help of this, finally the process data will be sent to end user. Okay. And the arrangement of a different layer in IoT system, that is again important. So we have discussed that the different protocols are connected to these IoT devices. Like we have application layer, we have service layer, we have network layer, device layer, and the arrangement is like this. The device layers will collect the data, with the help of some sensors, actuators, and that data will get transferred with the help of some Bluetooth or Wi-Fi or RFID ProLAN, WProLAN to cloud. Okay. So again, that network layer will transport the data from cloud to analysis. Okay. Then we require some kind of support or specific support. Okay, to collect that data. And finally, after processing that data with the help of some ML algorithm or stream analytics, it will get sent to particular IoT applications like application where that data will get uh, pass on to end user. Okay. So these are some examples which is given like smart cities, smart transport systems, smart buildings, smart energy, smart industries, smart health or smart living. We are implementing all these layers. We are implementing all these sensors to sense the data. We are collecting the data at cloud or some store, external store. Like we have a SQL server, and then based on this, we can analyze the data and finally we can send to end user. Okay. So look at the arrangement, how these layers are working. That is important. At device layer, what we have. So basically, it is for various sector like transportation, healthcare, agricultural. We have different types of devices and sensors. Like we have GPS sensor, we have gyroscope sensor, accelerometer, Wi-Fi, Ethernet, Bluetooth. So this provides user interface for which are using IoT systems. So these sensors are just collecting that data in device layer. In case of network layer, it is high performance network infrastructure is required. It is supporting some kind of communications for your bandwidth or security. Okay. So what we have encryption, we have LTE Wi-Fi module, GSM, and microcontroller embedded systems. So basically, what the sensors are connected to microcontroller and embedded system in network layer. Okay, and that are collecting that data, and the same data is collecting from different sensors, and it is used for multiple organizations. So data will get shared and it will get sent to all the connected networks in network layer with the help of this controller, microcontroller, and embedded system. Then next we have service layer. Okay, so the service layer is also known as application service layer. So it is capturing of periodic sensor data. It can use data analytics, streaming analytics. It can use service layer, and it can ensure the security and privacy of data. Okay, so machine learning algorithm can use for this service layer to analyze the data. Okay, and lastly, we have application layer, the lowest abstraction layer. It is digital system, nervous system, you can say. It is again collecting and process the real-time information like transportation system, health system, tracing the people, climatic condition. Okay. So it can connect physical and digital world basically, and it can measure the physical quantities basically in application there. Okay. Now, important part is what is difference between embedded system and IoT system. Okay. So this embedded system and IoT system, just I will tell you how these systems are connected to each other, differ each other. So if you go with the embedded system, so embedded devices, so what we have, embedded devices specifically, we can define a specialized computing system. It is designed to perform dedicated function at a larger system as a part of larger system. Whereas IoT is network connected system. Okay, it can collect, process, and exchange the data. Now, if you go with the connectivity, it typically operates a standalone device with limited connectivity, has limited connectivity, but it is connected to network. IoT devices are connected to internet or local facilities. It can facilitate the data, it can exchange, and remote management facilities available. But in case of embedded devices, the limitations are that data is because this system is operating standalone and it has limited connectivity. So it is not feasible to operate that system at remote management. Then purpose, execute a specific function within a system. And in case of IoT devices, it is integrated with broader ecosystem like for monitoring, control, and data. Then hardware complexity. So again, it has limited processing power and memory, whereas we can use network security and data processing in IoT. So if you go with the embedded system, these embedded systems are basically used for some certain kind of limited applications. Okay, where we can only measure the data and we can store the data. We can sense the data for particular specific conditions or applications, we can say. Whereas in IoT devices, n number of sensors are integrated to each other. Data will get stored, analyzed, and then it will get processed. Okay. So if you go with the processing part, Minimal data processing is only happening at embedded system. So as in case of IoT systems, it is capable for processing locally data, or you can say data at cloud for further analytics and decision making. Then we have security consideration. Security measures minimal due to limited connectivity. And in case of these IoT devices, it requires robust security protocol due to exposure to network-based threats. Then examples, automotive engine control units. Then we have microwave control digital units. In, in case of IoT devices, we have smart thermostats connected to security cameras. We have wearable health monitors. So this is the difference between embedded devices and IoT devices. So thank you all. And in the next class, we'll discuss the part of that connectivity. Okay.